Hi everyone. So, you may or may not know, but I actually love solving mathematical problems and some riddles, mathematical puzzles, and everything like that. So, someone recently actually gave me a mathematical problem, and I think it would be very interesting problem to solve. So, without further ado, let's start with it. So, here goes the problem. So, this is the equation that was given, and the question was to solve for x. So again, let me reiterate the question. So this is the equation that was given, and we have to solve for x. So we need to find out the values for x for which it would be satisfied. So if you guys want to try it on your own and try to solve this problem, you're welcome, and you can pause this video right now and try it on yourself. Your approach might be different from how I am actually approaching this problem, so it might be very interesting to see what other approaches that we see for solving this problem. So pause this video, and afterwards you can come back and see how I am trying to solve it. Okay, hopefully you have tried it on your own and you have probably find the right answer. So let me try how I am basically trying to solve this problem. Okay, so whenever you actually see this kind of equations, one of the first thing that you need to try to do, at least what I try to do, is trying to find patterns, like how are these intimidating numbers are related to each other. And the first thing that comes to my mind is 8 seems to be the uh, three cube third power, or to the power 3 of 2, and similarly 27 basically is 3 to the power 3, right? So this is how I start, and I can basically write this equation as 2 cube, which is basically 8, to the power x, and then I write, so this is just the parenthesis with my bad handwriting, and then 27 I can write it as 3 to the power 3 to the power x, and then so what about the denominator? Now we have tried to simplify the numerator, right, by writing 8 to the power x as 2 cube to the power x, and 27 to the power x as 3 cube to the power x. Now one of the goal is, can we find some patterns in it, right, as I said, and we have already started writing it as in terms of 2 and 3, right, which is kind of the basic, the most basic that we can go. So can we write 12 in terms of 2 and 3, or some power of it? And it turns out we can, right? So 12, it's basically 4 into 3, and 4 is basically 2 square. So 2 square is 4, and if you just multiply it with 3, you get 12. Similarly 18, we can think of it as 9 into 2. So 9 is basically again 3 square, and then if you multiply it with 2, you get 18. So now it looks very interesting, right? Because now 12 to the power x, you can write 2 square into 3 to the power x, plus you can write 18 as 2 into 3 square to the power x. Now it looks very interesting. So in the numerator we have 2 cube to the power x plus 3 cube to the power x, and in the denominator we have 2 square into 3 whole to the power x plus 2 into 3 square whole to the power x. Okay, equals to 7 by 6. Let's just, for simplicity, let's forget about this part. Now you might have heard about power laws, right, or how basically exponential works. So if I have something like x to the power a whole to the power y, we can write it as x to the power ay, right? And then we can again do x to the power y to the power a. So we can basically exchange the exponents, power of the power, right? So we would do something very similar with this side, where let it write 2 to the power x whole cube. So I basically take, if I just simplify 2 to the power 3 whole to the power x, it would become 2 to the power 3x, and then put the x here, and did 2 to the power x plus whole cube, just similar to this one, what I have done in the left hand side. And Similarly, I can write it as 3 to the power x whole cube. Okay, so this is for the numerator. In the denominator as well, can we do something to basically have it in this way? I suppose we can, right? Because if we just open up, so again, the next way, like if I have x to the power a, and say y to the power something else, b, and now if I have all to the power c, I can actually, when I actually try to simplify it, it would be x to the power ac into y to the power bc, right? So now I can do something similar here for the denominator part. I have 2 square into 3 to the power x, so if I try to simplify it, it would be 2 to the power 2x into 3 to the power x. Similarly, again this part will be 2 to the power x into 3 to the power 2x. Okay, now it looks very familiar, right? So now again it would be like, let's keep the numerator same, 3 to the power x whole cube. But now what we can do, here are some common terms, right? We can actually take some things common, and to me it seems like 2 to the power x and 3 to the power x can be taken common, right? And if I take this one out, what would be remaining? We would be stranded with 2 to the power x plus 3 to the power x. Okay, now we have actually done a pretty good job, right? Because we have found the pattern of the equation. So just to simplify the term so that we don't have to write it again, this whole cumbersome things, let's assume that okay, let me write it properly. So let's assume 2 to the power x as a and 3 to the power x as b. Let's assume that for just for simplicity. Then how does our equation now holds true? Now we have a cube plus b cube divided by ab into a plus b equals to 7 by 6. If you remember the right hand side of the equation, it was 7 by 6. Now this problem is not that much intimidating, right? Because now we have kind of solved the crux of the problem. If you remember a cube plus b cube, we can write it as a plus b into a square minus ab plus b square, right? So this can be a plus b and a square minus ab plus b square, and we have ab into a plus b equals to 7 by 6. So we can cancel out a plus b, assuming that a not equals to minus b, that is a plus b not equals to 0. We are assuming that, but if it is, then again you can create a solution from that, like say if a plus b equals to 0, you can do like, okay, 2 to the power x plus 3 to the power x equals to 0. But then you would see like it might be it may not have any solution for x, right? So we can think like, okay, a plus b not equals to 0, and then we can cancel them out. Now this problem becomes a square minus ab plus b square divided by ab equals to 7 by 6. Okay, now it seems very easy, and just by seeing at it, we have a minus ab, and in the denominator we have ab. So probably what I would do is just add 1 both in the left hand side and right hand side. So I can do this, right? So I can just do plus 1 over here and plus 1 over here, which basically will be a square minus ab plus b square and plus ab, since I am adding 1, and this would become 13 by 6. 13 by 6. This ab would be cancelled out. Sorry, it would be not 1, it would be ab. So we have a square plus b square divided by ab equals to 13 by 6. Okay, now it looks easy enough. So what I can see simply is a as 2 and b is equal to 3. It seems it satisfies this equation. Similarly, a equals to minus 2, b is equal to minus 3. This also satisfies this equation. So we kind of find two sets of solutions. So from here we can say, okay, 2 to the power x can be either 2 or minus 2, right? And similarly 3 to the power x, which was our b, would be 3 or minus 3. So 2 is basically 2 to the power 1, and minus 2 is basically 2 to the power minus 1. Similarly, minus 3 is equal to 3 to the power minus 1. So just by equating the powers, because like the base is 2 or 3 at both places, now we can write solution x would be 1 or minus 1. So this holds true for x equals to 1 or minus 1. That's the answer. So I hope you might be actually followed my way of doing things, or you could be actually solving this on your own. So I would be very interested to know how you have solved, if it is different from mine. So please do share it in your comments if you have solved it in a different way. Hope you enjoyed this video, and if you want me to make similar videos, please let me know through the comment. Bye bye, keep learning.